Hello everyone. We are going to complete our last topic in this unit, regarding parallel lines at least. We are going to talk about auxiliary lines. And I'm going to get to a definition of an auxiliary line in a second. Why don't you take a look at the first two problems on the page here and see if you can figure out the answers before I go over them. So taking a look at number 1, we're looking for the measure of angle ABC, this big angle. I'm going to zoom in a little bit. Notice that you have some parallel lines, which really gives us quite a bit of information. If I know I have a 75-degree angle right here, I know this little guy down here is also 75. Those are alternate interior angles. And if I know this angle right here is 45 degrees, I know that angle is also 45 degrees because those two are also alternate interior angles. And then angle ABC would be the sum of those two angles, 45 and 75, last time I checked, was 120 degrees. Okay, let's take a look at number 2. And you see kind of a similar problem with some x's and y's, so hopefully we can set this up in a way that we don't have to do a whole lot of work. I'm going to zoom in a bit and notice that it says angle 1 is 16x minus 8. And it also says angle 3 is 14x plus 2. And hopefully you notice that both of these angles, since I know these lines are parallel, are going to be congruent because they are both corresponding angles. And we also know that the measure of angle 2 is 4 times y plus 8. And our job here is to figure out both x and y. Well, hopefully the first step isn't so bad. We're going to take 16x minus 8. Set that equal to 14x plus 2, because we know those are corresponding angles. And doing some not so complicated algebra, hopefully you get 2x equals 10 and x equals 5. And now once I know that, I'm going to substitute that x value back into, actually both of these just to make sure I got the same. And when I did that, I ended up with 72 degrees in both cases. I'm going to mark that in blue. And actually that tells me even a little bit more. If I know that's 72, I know enough about linear pairs that I know that's 108. And if I know that one's 108, notice that I have yet another set of parallel lines marked with this one and that one, which tells me that this one also has to be 108. And now I think I have enough information to set up an equation to solve for y. So I'm going to give myself a little bit more room. And I know that 4 times y plus 8 plus 108 has to equal 180 degrees. And I'll remind you that what we have here is a line. And I figured out that that one's 108, which means that one plus the missing angle will equal 108. And then once again, doing some hopefully not terrible algebra, I have 4y plus 38 plus 108 equals 180. 4y plus 140 equals 180. 4y equals 40. Y equals 10. And if you did plug that back in, you probably got 72 degrees for this one here, which is good because it should add up to 108. And maybe you were saying, we didn't even have to do any of that. We already knew that that angle was 72, and if you thought that, good for you. If we see that we have two sets of parallel lines, notice that those two are vertical angles, so that one also has to be 72. And using this line as a transversal, and I'm going to grab the highlighter, and those lines which are parallel, hopefully you see that this angle right here is also a corresponding angle. So either which way you got it, 5 and 10 are the answers that we're looking for. All right, let's move on. Now that was a nice little bit of review of some properties of parallel lines. What we're going to talk about today are properties of parallel lines, but we're going to add actually another tool that we can use. We've come across pictures like this before where you don't really have a transversal, because remember a transversal hits both parallel lines, and neither of these do. So we're going to use something called an auxiliary line to help us with problems like this, and really, loosely said, an auxiliary line is really just an extra line. And as we've talked about before when we talked about our axioms, we can draw a line anywhere we want to as long as we have 2 points to connect. And if we keep that axiom in mind, we can actually solve problems in a lot of different ways and without having to do quite as many calculations as you might think you have to. So let's get started, and you'll see what I mean. Take a look at exercise 1. And again, I'm going to zoom in because I need a little bit of space here. Use auxiliary lines to find the unknown label angle. Well, this problem might seem familiar to what we saw on the previous page, but I'm going to suggest that we carry on just a little bit differently. Remember that we have always had the power to extend lines. So I'm going to go on ahead and extend this line right here. And I'm going to do the same thing with the line below. But what I'm also going to do is I'm going to extend the transversal. So I'm going to take this right here and draw a straight line. Now I hope you see that just by drawing in that little extension, we've made this into a very familiar problem. We have two parallel lines cut by this blue transversal. If I know this angle is 144 degrees, I know this angle is 144 degrees. Those are alternate interior angles. And if I know that this angle is 144 degrees, I see a linear pair, which tells me that the angle adjacent to it has to be 36 degrees, because it has to add to 180. And now noticing that I have a triangle here, subtracting 56 and 36 from 180, that leaves me with 88 degrees for that angle. And once again, I have another linear pair, which finally tells me that the measure of angle 1 has to be 180 minus 88, which leaves me with 92 degrees. Now really, when you think about it, there's nothing new in that problem, just the fact that we extended that line a little bit. Let's take a look at number 2. And I'm going to suggest we start it the same way by extending all of the lines that might be helpful to us. And you can see I extended both of the parallel lines, and I chose to extend this transversal. I'm wondering how many of you chose to extend that one, which would work very much the same way, so don't change your work. And now I'm going to just sort of carry on exactly the way I did last time. I have a 35-degree angle there. I know that that angle has to be 35. I see a linear pair with this 72-degree angle. So I'm going to subtract that from 180 and get 108 for that angle right there. And then subtracting 35 and 108 from 180, I get 37 degrees for that angle, which is vertical to angle 2. So I know that angle 2 equals 37 degrees. Now keep in mind, if you did do it the other way, if I erased all of this, and extended the other transversal, again notice that we quite literally have the same problem. 35 degrees from the vertical, 108 from the linear pair, 37 degrees to make that triangle add up to 180. And notice that angle 2, this one right here that we're looking for, would be corresponding with that 37 degrees, and we're going to get the same answer. Okay, let's move on. Okay, just a quick review, and we've already talked about the sum of the angles of a triangle. We know that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. I'm going to suggest that you pause the video and complete these exercises for yourself. Kind of a nice review of parallel lines and triangles, and maybe you might draw in an auxiliary line or so. Taking a look at the first one, a couple different ways to go here. Looking at the linear pair, we know this angle is equal to 102. Subtracting 42 and 102 from 180, we get 36. Or maybe you might remember a shorter way that the sum of the exterior angle is equal to the sum of the two remote interior angles. So if you remembered that, you didn't even have to find that 102. Moving on to number 2. Again, you see some parallel lines. I see this angle of 57 degrees, and I know this one right here must also be 57 because they are alternate interior angles. Looking at this linear pair you see right here, I know that the angle adjacent to that must be 86 degrees because it has to add to 180. And then subtracting 86 and 57 from 180, I get 37 degrees right there. And once again, I see another linear pair, so subtracting 37 from 180, I get the measure of angle 2 to be 143 degrees. I hope you're starting to see how similar these problems are. Let's take a look at angle 3 and angle 4. Once again, I see some parallel lines and I see some alternate interior angles. Angle 3 will be 46 degrees. And again, using the same idea, knowing that I have an angle of 94 right here, that angle right adjacent to it has to be 86 degrees. And subtracting 86 and 46 from 180, I end up with 48 degrees for angle 4. And lastly, looking at number 4, I don't see any parallel lines, but I do see that I have this line, and although there's 3 angles there, they still all will add up to 180, which means 58 and 93, this little angle in the middle has to be 21 degrees, because it has to add up to 180. And looking over at angle 5, I hope you see that there's a little triangle here. We probably could have done that right off the bat. So adding those angles up, the 58 and the 68, and subtracting from 180, we end up with 54 degrees. And lastly, once again, you have a linear pair, so subtracting 68 from 180, you end up with 112. And subtracting 112 and 29 from 180, angle 6 is 39 degrees. I hope this felt like a pretty good refresher of some parallel lines and triangles. That was largely the intent. But let's move on. Okay, and lastly, once again, I'm going to suggest that you pause the video and try these 3 problems for yourself. These are very much review problems. And then unpause it and see if our answers match up. In 5, I've drawn a triangle whose angles measure x, 3x, and 5x minus 54. And adding those 3 angles up to 180 and solving for x, I ended up with x equals 26. In number 6, notice I've drawn a triangle ABC with the angle measures x, 4x minus 21, and 5x plus 1. Inside there, combining some like terms, I end up with 10x equals 200, or x equals 20. But notice that you are not to stop there. We are looking for the degree measure of each angle. So I'm almost there. I know that x is 20. Angle B is 59 degrees, and C would be 101 degrees. And probably a good idea to double check that adding those 3 up actually give you 180 degrees, which they do, just to sort of double check yourself. And same question in number 7. Measure of angle A is x plus 56. Measure of angle B is x squared, and C is negative 6x plus 100, setting that equal to 180. I hope you notice you have an x squared here, so we solve this equation a little differently. I'm going to combine some like terms, and instead of moving all the numbers over to the right side, I'm going to actually move the 180 over to the left because I want to set this quadratic equation equal to 0. And when I do, I end up with 24, and I don't know how well you remember how to factor. This won't show up on our unit test, but you did do a whole lot of this last year. Remember, you're looking for numbers that multiply to negative 24 and add to a negative 5. Hopefully it doesn't take you too much trouble to come up with negative 8 and 3, and you end up with x equals 8 and x equals negative 3. Now, normally people are quick to throw out this negative answer, but be careful here. When you plug in the 8, you do get nice answers here. You end up with 64 for A, 64 for B, and 52 for C, which does all add up to 180. But what if we plugged in the negative 3? Well, if I plugged it into A, negative 3 plus 56 is 53. Plug it into B, negative 3 squared is 9. Plug it into C, we end up with 118. It gives us all positive answers for our angles, and they do in fact add up to 180. So in this case, actually, both sets of answers are okay. As I said, quadratic equations, meaning ones with the x squared, not going to show up on the test, just kind of a friendly algebra review. Homework is on Schoology. Email me if you have any questions.